And once you upset the balance, well, you trigger off a lot of things that are happening. And at that point, if you have a device for collecting the energy, you've got a generator, because the generators don't make electricity. They simply, by the coils and the magnets moving in relation to each other, they upset the background balance. And when that happens, well, then you've got energy available. And if you have a way of collecting it, you've got energy. And it comes from the ambient background. And how do we know that? Of course, from here to here, there's not much going on, because both places have the same ambient background. But if you look at how that ambient background got there, which would be, we can take the Earth. The Earth, it rotates at a certain speed and it has a certain weight. So we can take that and we can calculate the amount of energy that it takes to make the Earth turn, and then we can convert that into watts, and we know exactly what the ambient background is, which is enormous.
Yeah.
And this device here, of course, is, you see the field out here? I can go quite some distance from it, and any collector system I put inside this magnetic field will generate just like an ordinary generator. And
Magnetic field or E-field?
Huh?
Magnetic field or E-field?
You know, this is used for tracing wires and things, but it also, the magnetic flux in the area is what's running it. So, and you can get these at Sears and Roebuck or just about anywhere else. You know something we didn't bring in? Well, this one, the battery's run down on it, that's why it's not working, but this one is working just fine. But,
Okay, got the thing looking for you.
yeah,
Whoops, careful.
my briefcase, I need it, and I've got all kinds of, where did I put it? Or did I even bring it in?
Run a battery you need, I guess. AA.
It may still be sitting out by the thing out there, and it may still be in the automobile. It's going to be interesting to do the speech without my overheads. We do have one overhead, which we can put on there if you want. I think I left my briefcase in the automobile.
That's 0.47.
Okay, suppose somebody handed you this particular slide that you're looking at, and you would wonder, well, what's going on there? How many of you are familiar with this? No one familiar with it?
Yes. Testerica system?
Yeah, that came out of the Australian deal.
Australia?
Yeah. Okay. Okay, are we hooked up? It's okay? You picked me up?
Can you hear all right, Atlas?
Can you hear me back there? Okay, well, I get a signal from the back that we're doing okay, and unfortunately, when I got out of the car and got the things out, I had an enormous number of real nice slides that I had made to show you, and really I don't have any of them, so I'm going to have to do this without the slides or other things. So what I think we can do, excuse me, down here. Okay, what we can do, I'm sure that there are plenty of questions out here, and you're familiar enough with the types of things I do that you can, we'll just kind of start, and take you one at a time, and we'll do your questions since we don't have any slides. So, who would like to start it off? We start over here.
Yes, with your particular first unit down there on the
Okay, I have a little bit of trouble hearing, so you're probably going to have to shout at me.
Yeah, I mean, if you'd like to give us an explanation of the fire unit.
Roger, why don't you go right up to him and...
Okay, you want to know about these devices?
Yes, just give us an
Okay,
explanation of the fire unit.
early on, when I started first studying electricity, the first device I'd like to show you will be this one. Okay, if people say that you can't get more out than you put in, this is a good example of it. It runs off of a 7 amp hour 12 volt battery, and this is a Tesla coil here with the L1 and the L2, and it puts out about 30,000 volts, this central Tesla coil here. So that magnetic field that we were talking about over here, it's all over the area. As a matter of fact, you can go anywhere in the neighborhood, and if you have another coil that's tuned to that same frequency, it will generate the same amount of electricity as the one that's in the center here. So if you notice the little neon 2 bulbs here, Radio Shack, okay, what they do is when you tune these other coils to match this one, due to the fact they're slightly different, you have to tune them. And when you do that, those little neon tube things light up. And I'm going to have to use a handkerchief. I had several strokes, and I don't have good control of my muscles in my mouth. So anyhow, you have basically 3 receivers here, and you have one that's producing, and so each of these will duplicate exactly what's here. So we've got 3 times more energy. Well, actually, we've got this one, and then we've got these 3, so we've got basically 4 times what we're putting in coming out. And it's undeniable, and it's if you can build 1 Tesla coil, you can build 3 more just like it, or 100 more like it, or you can fill the whole room up with other ones that match the same frequency. And so that should answer the question whether you can get more out than you put in. But actually, you're not getting something for nothing, because it was all there to begin with. All you're doing, you have a generating system, and you have a collection system, and you disturb the magnetic field around it, which is enormous, and it covers a large area, and anywhere in that magnetic field, it's going to equal whatever is coming out of this one. So if you want to build something which is relatively simple, which answers the question as to whether you can get more back than you originally put in it, this should blow anybody away that might not like what you're doing. So this I built about 15 years ago, and it's survived up to now, so you're getting to see it. Okay, we have a lot more to talk about than we have time to cover. Oops. Okay, I want to ask you, does this look familiar in any way?
Tom Bearden's unit.
Okay, this is Tom Bearden's device about 10 years before Tom Bearden knew that he could do it. And this is the one that was in the black suitcase in the 1996 presentation at the Tesla convention in Colorado Springs. It did there were engineers in the audience that had their instruments with them, and they tested it as producing 120 volts at 80 amps. So this is kind of small for something that's coming out of a 7 amp hour 12 volt battery. So these things become self-sufficient when that happens, because all you have to do is have an extra tap off of the thing there, and that will produce more electricity than is required to run the device. So once you get that initial ignition going, it's self-sustaining. And there's no moving parts here, and if you stay within the tolerance of the parts, it will probably last for a very long time.
Okay. Am I right if I think that one bar is the positive?
Oh, you see the one that extra wire that's in there? That's something that Tom Bearden didn't have. But how that happened was I used the wire that you use to hook up speaker systems. The reason for it was the fact that it was multi-stranded. And I thought, well, I would just have to pull these apart in order to get a single wire so that the thing will work. So I decided to leave the second wire in there and turn it into an antenna system for, whoop! It's charged right now. It's running right now. Anybody care to come up and touch it? It's kind of like touching a thing you poke cows with.
Am I right if I think that one wire is on positive and the other wire is on
Well, what it does, it boosts the ambient background that it's exposed to, so it supercharges it. This thing puts out, well, Bearden was getting a 1.8, I think, on the return on it. Well, this one will get maybe about 20 or 30 times that. And it's probably due to that little antenna wire there that I just accidentally touched.
So,
It's high frequency, that's why it didn't kill me.
is that a battery on the left? What do we have here on the
Yeah,
left?
what's the circuit?
Let's say again, please.
Battery? Is that a battery?
It doesn't even have a battery on it right now. It's running.
transformer.
It's running at full force. I mean,
Wow.
to tell you, it's like getting hit with a cattle prod thing
Okay.
and no battery.
I would just,
If anybody cares to test me on that, well, they're entirely welcome.
Clip a neon bulb to it.
Could you explain the components?
And how this came about, I won't be able to hear you very well, so you'll have to get me later with your questions. But how this came about, you see the toroid that's in there? The United States government bought a lot of those things out of Alamogordo, New Mexico, and they paid about $10,000 a piece for them. And I found a whole box full of them in a surplus place. I didn't have the slightest idea of what they were or what they were used for, and I didn't know what met glass was at that time. No one else did either, because it was highly classified. And when Signal and the other people declassified it, well, that's the first time I realized what I actually had, because what they what this is, it's a toroid, but you make it with tape of it's a metal tape, silicone steel type thing, and you wrap it around a form, and you get any size or shape or form, whether round or square or oblong or whatever, and that's how you get the toroids. I have some of these that are 14 inches in diameter, and they probably cost the government probably $500,000 a piece, and I've got 6 of them. And in my website, you'll see a large round toroid that's on a little push cart, and it's got a Tesla coil built on that thing. Well, what happens there when you do that, it's a cyclotron type deal, and once you get the electrical field circulating in that closed system there, you can put other coils around it, however many of you want, and you're not taking electricity. None of the electricity that started out in the system ever gets through it. It's the point A and point B thing where you get electrons jumping up and down at point A, and they do not go from point A to point B. At point B, they jump up and down in resonance to the ones at point A. That's your resonant energy type thing. So once you get the resonant energy type thing going, and you get the magnetic fields going and that sort of thing, well, you can tap off of that system without taking away from it. And you can take off as many other coils as you can get into the area or onto the system. You can take that much off, and it's not affecting what's being put in any respect. And it's highly obvious, and it also people will tell you can't do this sort of thing, but you've already seen one example here when I got shocked just a minute ago. And those that are skeptical about it, I invite you to come up and touch the thing here and tell us that it's not working.
Well, we've done some experience too with those kind of coil with two wires on.
But you have to kind of shout at me.
We thought the same thing as you. We had the speaker
On your
wire.
questions, what we probably have to do is wait until question and answer session, and then I'll try to get you one at one. And if that don't work, I've got a website and I've got an email address, and you can ask me on that, and I'll answer you and put it on the Yahoo thing so that everybody will see your question and your answer.
If you want
So that may be the best way to do it.
we can have somebody come up. We can have somebody come up here and ask you the question.
Yeah, if they would like to come up individually, and that's how I learn. That's when you guys ask me questions. Well, that's how I learn some more. So I not only know what I know, but I end up knowing what you know. So this is one device.
Okay. Have you experimented?
Working from photograph there, the pancake type deal, is that what you want to ask about?
Yes.
And you want some general statements on it as to why it works and how it works and that sort of thing? Okay, whenever you take take a coil and instead of being a normal, let me put this down before I touch it again. In a coil system, like in a normal Tesla coil, they're normally high and skinny and that sort of thing. That's the wrong way to go if you're wanting amps and stuff, because the length is volts and the diameter is amps. So if you get the right combination of this versus this, then you got plenty of amps and plenty of volts. So. And also, depending on how you tap onto the coil, will determine whether you get amperage. But there's the same amount of amps there as there are volts, because in the magnetic system that's driving it, it has to be equal and opposite. That's your Lenz's law, you know, it's equal and opposite. So that means that one of those is your magnetic or your field, and the other is the electrical field. And the magnetic field is amps.
Okay. And what about bifilar coil?
On the
A bipolar coil.
Bifilar coil.
how does it magnet? What's the ratio? Okay, whenever the center of the pancake coil is certain size, and the outer ring is a certain size, and then the L1 coil is maybe a couple of turns on the outside of it. So the ratio of the diameter of the inside versus the outside turn on it is the improvement or the advantage that you gain by doing it that way. So in the one that's in the picture in the book there, the ratio is 1 to 5. So not only do you get the L1 and L2 gain, you get 5 times that. So that's the advantage of pancake coil.
But they are one wire or B wire?
The outside, well, the L1 wire should be an even division of whatever the length of the L2 is. That way they're able to talk to each other. The frequency, if you worry about the frequency, don't worry about that. Just build the thing so it looks nice and make an even division, multiple or even division of the lengths of the wires that you want to talk to each other, and they'll be talking to each other.
What's the ratio?
The ratio in the case of the one that's in the book is 1 to 5. So it's 5 times what, plus the fact that it's a normal Tesla coil. Your normal gain times 5.
Do you ever do quarter of the wavelength like Tesla did?
And what?
Do you ever do quarter of the wavelength like Tesla did for his coils?
Well, they will be able to talk to each other, and you can calculate the wavelength because you take the speed of light and divide that by a certain factor, and that will tell you how long the wire will be for a certain frequency. What I did on that particular one, I used about 200 megahertz, which meant the wire was going to be about 18 to 20 feet long. I think it was 18 something. And then once I had the main frequency set up, then I made the other coil. So as long as it's a even division or a multiple of, whichever way you go, they're going to talk to each other, and that's all you need. Okay. There are a lot of different things. This thing's a little bit heavy, and I see it's got a lot of sawdust on it because it was sitting. Let's see which way to turn it. We don't want this to fall out. Can you see it okay?
Yes.
Okay, you notice that this main coil there has the center part of it cut out, and the 2 cut things are brought over as your ground deal. Okay, and the ends, the electrons are spinning one direction, going this way, and spinning the other direction going that way. So you've got electricity and you've got amps. And when they come together, then it continues on. So you've put the 2 together, and you've got more amps than you know what to do with, and more electricity than you know what to do with. So it has to be cut back. This is a diode bridge here. You go in and out of these inverter systems. Since this thing has to run on alternating current at 120 volts, in order to get to that from the battery, I had to use an inverter, and people make fun of me because I use Radio Shack inverters, but in this case, the high voltage thing there has to run off of 120 volts at 60 cycles. So that's how I get to there. Now I've got a rheostat here where I can raise and lower the input so that over here it comes out to the correct amount that I want. And on the process, this is 8,000, well, it's 2,000 volts each. So it ends up being like 8,000 volts, so I have to be careful not to get beyond that. And they're 8 microfarads each. Now I have some 50 farad capacitors, which are newly available on the market, and they actually go up to well beyond that. But the trouble, the way they manufacture them today, they are down in the voltage level, which is too low. So by paralleling them and other ways, you get up in the voltage range that you want.
So you use a supercapacitor,
Yeah,
ultracapacitor.
I have several of them, and I use them in some of my larger units. And I mean, tell you, one like this, if you stick a screwdriver in there while it's running, about half the screwdriver evaporates. I know, but it makes a noise. It'll unnerve you and the whole neighborhood. You'll have everybody in the neighborhood for blocks around. They're running outside to see where the explosion was, and you'll end up with a screwdriver with a handle with just a little bit of metal left on it.
Why do you have the white cap on one side of those
What is he asking?
secondaries?
Well, the capacitor on your
Why
LCD.
that one there?
Because it seems symmetrical there, except
When I got to that point, it was out of tune. So I had to do some tuning on it to keep it going on. And the reason for this is it's also a tuning mechanism, but it turned out when I got built, it didn't really need very much tuning. So I never really had much. This is your old slide radio thing, or your tuning antennas, and the L1 is the red that's on the inside there, and this is your L2 system, but it's a double one set up so that the amps and volts and everything are in there in a proper order. And this one I built in 1994. So, and there are over 200 of these different devices in existence right now, and the more recent ones are subject to business deals and things, so I can't show you them. But the idea is to try to fix it so that you can get the idea and you can build your own. And actuality, I had something in my briefcase that I wanted to give you because everyone wants schematics. And this particular one was so simple that it was ridiculous. And what I'll have to do is just give it to Bruce here and let him post it. Because I actually ran out of ink printing the darn things up to bring over to you. And then I apparently walked off and left them. And I had a lot of help this morning in getting here, and that's why I was late. But anyhow, how are we doing? We have how many minutes?
Hour?
We have
60 minutes?
another hour? Okay, well, we can still do it. So this is, let me tell you about these. People were asking me about them, and they're not something that you can buy. They're not in a catalog anywhere. And when I called Cornell Dubier and asked them, do you have this? And they're very high voltage. If I remember correctly, they're about 10,000 volts. And they're 0.5, if I remember correctly, 0.5 microfarads, which by anyone's, they're difficult, they're impossible to find, is what I'm leading up to. So Cornell Dubier asked me what I wanted them for, and I told them I needed them for research and development, and they said, well how many can you use? And I said maybe a dozen or so, and they said, well, they're I think they were $300, $350 each, and they said, well, fine, you'll be hearing from us. And I forgot about it, and about 6 months later, they showed up in the mailbox, and for free, compliments of Cornell Dubier. So I've found out how to work that system now. And so I've got a lot of things which don't really on the market exist. They exist in people's minds, but they're not. There's not a demand for them. So that'll give you some idea about it. Now, these diodes here, again, like I said on the Tesla coil, the length is the voltage and the diameter is the amperage. Well, the same thing holds true on diodes. And it probably holds true on a lot of other things. So these diodes are long, and these are 25,000 volt diodes. So they give you some idea. So everything that's in here is probably an overkill, but the results are real interesting, and it does work. So
The device right beside the caps, is that a
What's he
spark
asking?
arrestor?
Right, the device beside the caps.
what that is?
Yeah.
Okay, a lot of your electronic devices have things which control the voltage, you know, like spark gaps. That is a radio frequency spark gap. It's used for lightning arresters on computers and things that are sensitive to voltage. So if lightning hits, well, anything over a certain amount will go to ground. So that's the ground post on that high voltage thing there. And so I'm grounding it back into itself. So when it's running, that flashes. You see the flashes in it all the time. That's like my little neon things that I use to check the circuit with, so that a lot of times I'll put them in different places, and I know up to that point that everything is okay, because when it's running they light up. So that's getting pretty heavy about now, isn't it? Okay. This device that you see on the slide up here, and all of these things, you have a dipole type deal where you have minus and plus and so on and so on. So if you have a situation like that and you interfere with that with some sort of collection device, then you've got a generator. So you'll notice that there's nothing, no input on this except the ambient around it. And if you go back to Faraday in the very early days of the Faraday generators, they were basically magnets with some sort of something that would interfere with them that would cause them to kind of go off and on. Well, in this case, the plus and minus are on the poles of the magnet, and you're interfering with them in a certain way, so therefore you're getting 700 volts. And this is straight out of the air with no, you see the little antenna things like that second wire that I have on my other device? Well, that winding up there simply is taking from the air, the ambient background, which is enormous. If you do the calculations, Seraway's university textbook for professionals in college physics, Seraway, and he's actually the editor of the book. Each chapter, which there are many chapters there, are done by some worldwide expert on that particular subject. So the part on the electricity and such is done by a certain professor at a certain university. So Seraway is the editor of the book, and it's a collection of experts from all over the world, and it's used as professional physics for the in the university. It's the one where they get their start. So it's the one that has the statement about the Earth, or the weight of the Earth, and this and that, and since we can calculate the ambient background from the movement of the device, current movement is always in the direction of the current movement. So if we take this, the energy coming in from outer space, we think of the sun as being the major source of energy. It's just a tiny bit of it. If you look at the electromagnetic spectrum, you have from, say, a few cycles per second into the thousands of gigahertz, I guess, sort of thing, and the sun is kind of in the middle. So why this matters is that when you have a swing, current swing like that from plus to minus, that's like the speed on a generator. If you run it, say at 700 cycles per second, you get a certain amount. You run it at 2,100 cycles per second, you get more. It's a rate of disturbance that's going on there of this ambient background. The generator is not generating electricity at all. It's actually disturbing the ambient background, and it's collecting the energy out of it. Now, all of these devices are doing the same thing, except they're doing it with radio type devices. And if you want to see that, the computer programs for schematics, if you get one that's with a linear, nonlinear system, which quite a few of them are, and an open system, which quite a few of them are, you can actually do the schematics on these things, and these programs have an oscilloscope and all your meters and things, the virtual ones built into it, and you can build your device with schematics, and you can test it and see how it's working, and then you can play by switching out pieces until you get the right combination. And I can tell you that these things which are called over unity show up absolutely the way they are. They're not, some of them may be rigged, but the ones, there's several of them that I know about. The first one I picked up off the internet out of Slovenia. And they had a lot of examples. They had done dozens of examples of schematics where the output was thousands of times greater than the input, and that sort of thing. And they gave the schematics that they did and showed what they looked like on the virtual instruments. And it was highly obvious that there was nothing terribly unusual about getting what people might call over unity. But over unity is an albatross that's hung on it in order to make the person look ridiculous that thinks that it might be there. So it's intentional, and it's written into all the books. And this all started back when Tesla confronted some people early in the century, and they found out that there were things out there which might be disturbing to their monetary interests, and so since they contribute to the universities and this and that, well, they started making sure that when the books were published that they all of that was written out of them, and they still do. There are a few people that are bold enough to write books that are in universities, but generally speaking, they don't last very long. If they don't, university is there for the system, and it's there to make a rubber stamp out of you. And if you don't like being a rubber stamp, you're in big trouble. And apparently there are enough people with that renegade attitude that it's beginning to change. I also forgot to show you this. It's called an electrosensor, and it does the same thing as the other deals I have here, except it measures in Gauss. And this thing is greater than 30 Gauss, and if you convert that into electricity, based on the original definition of a Gauss, if you do it the way the textbooks tell you, you'll end up with something that's not significant. But 1 Gauss is equal to 100 volts, RMS, or 100 watts rather. So when you get into your coulombs and your watts and all this and that, the definition is the same for all of them. If you notice, if they're 1 volt or 1 second, it's such and such. So it ends up with a coulomb, a watt, and so on. There are about 4 of those things, and they're all actually the same whenever you know the value. But Gauss, Hans Christian Oris and Gauss were professors over in Europe, and back quite some time ago, they were trying to measure the electrical value of the Earth's electrical system. And of course, one of them did it at night and one of them did it in daytime. So one of them got, let's see, it's 50,000 volts. And this is an imperfect measurement they made because they did it by flying a kite, or or a friend that likes to fly kites. And so the nighttime value is about half of what it is during the daytime. So this comes from the fact that in the Earth's rotation and when the Earth is spinning, it's spinning into the cosmos, so to speak. And on that spin in side, it has a greater electrical system than on the side that's away from it. So that's why the two are different. So you get like a Gauss is like 500,000. The way they were measuring it, equivalent to 500,000 volts, and the other one is, I think, about a fifth of that, if I remember correctly. When you get my age, you understand what's going on there. But anyhow, it's there, and if you got the right shovel, you can get it. And that's kind of what you're working on whenever you're attempting to intercept it or intercede. And of course, in order for it to work, you have to have more of something, and there has to be less somewhere else. So, and you have to, the leg in between the more and the less is the active system, which you're going to be using to get your useful energy. Because as these things are working right now, the energy is not useful, but you have to do certain things to them. And you can measure what's going on here, but you have to have, there's 3 or 4 different components that have to be in there in order to bring this down to where you can actually do something with it. And you can work it either from the backside into it. If you know what you want, then you can back engineer it through the system, or you can come the other way and put controls on it so that you can control the output on the other end. And also you need instruments that will work with radio frequency. The reason for radio frequency is that the more of these up and down things you have, it's whenever it changes direction there that it throws off either a magnetic or electrical wave. So on the electrical side, you're pretty well boxed in, and all the rules and the books and things, you're in Ohm's law and all that sort of thing. If you're in a closed system and you're boxed in, Ohm's law works. But if you get over, and that's on your electrical side, but when you move over onto the counterpart of it, the magnetic side, none of those laws apply. Right. and it's a whole different system, and most of the critical information there is missing intentionally. So, in effect, what you have on the magnetic side, you can make as many copies of it as you want without depleting the source. And that's where your units that you're interested in, why they work. If you know that, then you can just turn your nose up at those people that are trying to make it on the electrical side, because they require very low temperatures and a very complicated situation, and it's got you where you can't really do what you need to do. So if you're intent on doing it, stay off of the electrical side as much as you can. And let's see, how are we doing? We can stay here till this time next month and not get the subject covered. So if we can somehow maybe find out what's bothering someone here and see if we can untangle it for them.
I have a question.
Sure.
When you see the big power transmission systems,
Yes.
going through a right of way,
Sure.
some people have taken coils and put them where they can get some of that energy.
They're not taking away from the company at all. If the power company says you're stealing their electricity, they're exposing their ignorance, because it's just like the magnetic field around this thing. If I took something from it, put coils in it and produced electricity, it's not affecting the output at all.
So their statement that they can find those things by the power drain is just baloney.
They
Is that
can
right?
probably locate them because their radio, the magnetic field is repeating itself or reflecting out of the thing, which, for example, a common case there is where someone has a fence that's not grounded, that's running parallel to the power system, and it can be thousands of feet away, and that fence will have a charge on it that will kill you if you're not careful. But usually the humidity and other kinds of things ground it, so it's fairly safe. But what really happens is the power company, you have neither on matter or energy, it's neither destroyed or consumed. Everything is always there. It just simply flips over into some other temporary arrangement, and then it will end up going back to where it came from. So nothing has been used. So therefore, when the power company sends you an electric bill for electricity that you used, you did not use any. It just simply flowed through the system and went on out and went back into the system. So it's not used or worn out or degraded, or that's not the end of it at all. It's just like at your house when you turn the light switch on and ground that system into the earth ground. You haven't destroyed the electricity, nor when a machine heats up and there's heat involved and this and that, all of that electricity is still very much there. It just passed through a resistive point, and therefore you get the heat. But the heat is something in addition to what was already there. Just like if you put other coils in the system, you get repeat of energy in them. Well, that heat is just something which occurs as a side effect, and it in no way has degraded the electricity that's there. It just flows on through the system and goes back into it. So that's your ambient electrical system. Okay, I bet you we got another interesting question out there. Yes, sir.
We're supposed to come up, I guess?
Okay, couple I got from a buddy of mine, and then I want to ask a couple of mine.
Okay.
Okay.
Well, come over here.
Okay. Now, you always talk about where you have your business interest, your business buddies and stuff. And I know you got certain things you contract obligations. So, will you be able to lease your units anytime soon?
I myself am going to stay out of that. The various business interests are the ones that are going to be involved in that.
Yeah, I mean, nobody ever knows who the business interests are.
I wouldn't sell you a unit if you offered me cash. I've had people offer me like $5 million for one of these devices, and I've turned them down.
Yeah. No, I'm not trying to embarrass you. Anything.
No, I don't mind.
Who would we go talk to? You know, then,
Well,
do they have a link to
I
them
would
on
say just kind of wait and watch, and we're not looking for publicity. So if you ask me that question again one day soon, I might point you to somebody.
Okay. The other one he had was, have you solved the problem with needing a ground connection? If not, have you looked at the Hendershot circuit? We use the same principle.
Well, grounding works in several different ways. People think of earth grounding as being something that goes into the earth. Well, the Earth's atmosphere is also part of the earth. So you can have air grounding, or you can have ground grounding. And in citizen band radios and the ones that are in the automobiles moving around and things like that, they frequently are grounded into the metal body of the automobile. So, or if they're not that, then in actuality, that antenna that's sticking up there is grounding into the Earth's electrical system, and that's why you can pick up the radio station a long way off, because it's interfering with the magnetic system and it's sending out these waves that are different than what's normally there, so it's upset the electrical and magnetic balance, and that's why your receiver out there is receiving it.
So then we could just, see, the next one I have was like, were you working on anything to produce a fuelless aircraft? But that relates back to the ground. But if you don't have a ground, then you can use the car as a ground.
Well, when you're flying in an airplane and they have electrical systems,
right,
they're grounded into the metal parts of the airplane.
Right, and to drain off the stack and everything.
Yeah, and it radiates off of that. So grounding is a relative sort of thing. It's that there's more of something here and less of something here, so it's going to move between the more to the less of something, and it's that leg that's in between there that's your useful energy.
Okay. Now, my personal question, okay? You know, on the where you have the simple schematic right here like this?
Yeah, you'd be surprised that actually works.
Yeah, but when you
but there have been a lot of people that try to build it, and they weren't successful at it, and I can't guess as to why it wouldn't work, because I tried to make it as simple as I could.
Sure.
And I think what happens is people change the lengths of the wires, or something is a little bit changed there. Now, that is problematic, because depending on that power source there, some of them are self-grounded.
Right.
So, and that's where part of the confusion may come in, because sometimes when you hook that thing up, if you're not careful, everything you got goes there.
You short
and
it
that's
out
the end of it, so nothing happens out here, and as a result of that, it didn't work, and I was wrong.
On the capacitors, that's a great story. You know, I love it. But how can I get some? I mean, everybody else.
Well, you
I
just
can't get them from them, but-
you find something they don't have, and you just call them up, and you get into a nice conversation, and then they ask you, well, what do you want them for? And if you say research and development, well, they say, we have a department that takes care of research and development problems, and how many of them do you need? And then, of course, you tell them, and then 6 months later, after you've forgotten all about it, they turn up.
Start early, Monroe.
Because you talked about how you had some handout you wanted to do, and it was real simple. Could you draw it for us on this, and we could just copy it?
Well, yeah, I can draw it. I remember the
And give us
schematic.
part values. That's what I want. I want part values.
Do we have
so I can build
one of
something that
those
works.
blunt-looking black pencils that everybody can see? Or a piece of chalk, or that's a chalk deal, isn't it?
That's
dry
erase.
erase.
Dry erase. Dry erase.
Oh, right here. Go right here in the back.
something to mark on the board.
Here you go.
Oh, I think we're in business.
Bring it around, bring it around.
Hey, you got your colors too.
Move the board so we can film it.
Spin it around, okay.
I'm trying to get a, let's see, this cord is only so long, so, and not only that,
Move it over there?
when we get over here with this wire close to this thing
Oh,
going.
you don't want to put this thing in first, let's just put the thing in the middle down there.
Okay. Oh, that'll be fine.
Uh-oh.
Think I'm hung on that thing. I want to drop that. Okay, well, let's see if I can squeeze around this thing here.
Okay, I'll move it over here.
Let me get past it. Okay, we're in good shape.
See, my problem is like you got resistors with millions of ohms of, so you got millions of different values. I want specifics.
Well, the problem with that is that everyone, when they buy their wire and their other things, those things are not going to match what's on the list.
Give me the wire. Wire
all
down,
the things I do are generalities, and if you get one of those electronic schematic deals, you can fiddle with it all you want to, and you might get better results than what I would give you.
Go for it.
Okay.
I want something, when I walk away here today, I can build it and then put out, something to run a house. But a house, I know if I go, a house, that's like 10,000 watts. That's going to cost me too much in parts. But like on a house where I have a circuit breaker, I break it down, maybe a 10,000 watt part would cost
any
too
of
much,
these
and I can
things
build
that you
it.
get are going to produce more power than the system can handle.
Right.
So,
Oh, I understand, but the parts may cost me, or it may be parts I can't get.
So
I'll make a bunch of smaller
What
ones.
you do inside the circuit, you put these deals where circuit limiters like you have on your computers and telephone, protect them from spikes.
Right.
You put those
Gas
different
discharge
points
too?
all through there, and you set the only amount that can come out of it as the amount which you want to see at the end. So most of it's going to go out of the system, but you will end up with what you want at the end of the system.
Yeah, because I look at this, I see it as a giant breaker box. Here you got the primary. Okay, this is the living room. This is the bedroom. This is, another part.
You would only need that. On that deal, that one coil there in the center is more than you ever could use.
I mean, you know what I'm saying though? Because if the parts end up costing way too much, then I can't swing it. But if let's say if I wanted one unit, put out 10,000 or 100,000 watts, that's going to cost a lot. But I can build a couple of smaller units, the smaller coils or smaller circuits that were just dirt cheap.
What I recommend is you take the end product of what you want and work it backwards.
Give me specifics. That's what I want.
Okay, we'll see what goes on here.
Done.
Okay, this is a piece of material like same kind of chemical composition, say as met glass or piezoelectrical type material or what, maybe a rod. And of any size, it might be this size or this size or whatever. It depends on the amount of energy that you want out of the thing. So I'm working backwards on this. Okay.
10 kilowatts, enough to run a house.
In order for the system to work, you have to have off and on. It has to turn off and on. So what we're going to do is put a this is not exactly the symbol for it, but it's an NPN resistor, and this is the base. Okay, and let's see, I forget which way the arrows point here, so I'm going to leave the arrows off of it. But what happens, this is your input here, and this is your output here, and it comes over, and well, this is not going to be very pretty. And then this comes back here, and then okay, on the base down here we have a resistor which is controlling our timing device, which opens and closes the gate on this transistor, so that what's coming through here is going to be a certain frequency. You're setting the frequency there, and this is the first coil. Okay, there's a second coil or a number of other coils which are up here. Okay, and what's happening is the magnetic flux in this piece of metal here is set up such that any amount of coils you put up here will duplicate whatever's being put in here. So we have our input. I think it comes like this, and we have this one. There's another deal here, and this is going to be your negative side, and this okay, no, this is a negative right here, this is plus, and this is plus here. So this negative one here is coming back over here, and the output, this is your output here, and this is your main input here.
I have a question. In this, you have these two shorted together. Is that the right? Is this, or does this end up going?
And this one it goes around that one, and this one. Let's see.
Yeah, I just want to make sure because this looks like.
You want to know where the.
Well, it's interesting that this is shorted together up here. That it's completely shorted to this plus.
I won't swear that this is 100% correct, but the one that you will see later is.
Thanks.
But I think it may look illogical there in a place or two, but I think that's pretty close to correct. But you'll know later.
So have you come up with any new devices other than...
I come up with about 3 or 4 a day. I don't often have time to put them together. But I can say that once you get off onto something like this, that every one of them leads to something else. There's no such thing as one of them. It's kind of like a cat that wanders up at your house. There's no such thing as one of them. But at this point, someone had some questions a little bit ago that wanted to come up and ask them. Do we have someone else that would like to come up? Okay, where do you want me to stand? On this one over here?
This one has L1 and L2.
The small coil, the smaller one that's larger around is the L1. The middle coil is the L2.
Okay,
And that's just for convenience in naming them so that you know which one is which. And it's very possible that this thing is not tuned into that. That's the reason why it's not acting up. What made this one act up was this silicone steel toroid there.
is there a magnet inside, like in
No, it's the toroid in there. It's a toroid that's been flattened. Instead of being round, it's kind of rectangular. But how you make those, it's made that shape because it will fit into a particular component in some device. If it's big and round, it's going to take up more space. So by making it shaped like that, it will fit into, they will bite you, at least they were a while ago. I don't know whether they're doing it now, but it definitely bit me.
What is the frequency of this device?
What is what?
What is the frequency?
Frequency of it, of this particular one, I think it's 55,000 cycles per second. Is that the question?
Yes.
Okay. Frequently, when you build something like this, you end up with a frequency that you hadn't planned on, and when you work it out on the electronic programs, it will frequently turn out something different than what the program says, but they do kind of haunt you, so they're nice to have. Okay, we need probably, please come up. No. I bet you have a question. Surely I haven't answered everybody's question.
Well, I have one myself.
Okay.
Put it back on tripod for statement.
I've been really curious about this since you showed this leg
Okay,
right
what I've done there, two of these wires here normally come off to another system. So you're not seeing the complete system, you're seeing the main part of it. But I build parts of these systems on different little blocks, and then when I hook them up, well, I've got the whole system there. Now this has all of the different components on it, which sometimes, say this part over here, and this part will be on different blocks because I can use them interchangeably with other things I'm doing.
Is there a reason for this leg being disconnected?
Yeah, well, you notice that those two are loose. That's probably why it quit sparking there. This thing was, whenever I set it down in a certain way, well, it closes the system. And I noticed that when the fellow came up just now, it wasn't doing that, apparently. But whenever I touched it, it did.
These windings on the inside are...
If you look close, you can see that's like it's metal tape.
Right.
It comes on a roll, and they roll it around a form to get the shape they want, and then they dip it in shellac or something, and it stays put.
These coils, are they mirrored to each other?
Well, they're layers just like Scotch tape.
Right.
You know, and when they dip it in the lacquer stuff, well, they put it in a form and they keep it there until all that dries. And when it's dry, well, it's ready to be used.
This is something similar to this right here?
Well, they all do the same thing. They look very different, but basically it's your bucket for dipping the water.
Okay.
Is that it? Okay.
You had indicated you use software to.
Did you want some?
You had indicated you use software to model these, sort of like
What
Spice.
software?
A circuit analysis system. I guess you were talking about software that you use that would have displays. I assume that's something like Spice, the Berkeley Spice.
Okay, on the internet.
Or any of the free ones.
If you do a search on the internet, you come up with a great many different programs. One of the best ones, it's about a $9,000 program, is from the University of California at Berkeley, and they quit updating it maybe 10 or 15 years ago, and the university over in Slovenia picked it up, and they've been updating it, and then the University of Barcelona got in on it, and you can download it from the University of Physics Department at University of Barcelona, and it's about a program that you buy from a commercial source. That quality is about $9,000.
What's it
You
called?
can download it for free, but you have to know a little bit about it because the different components of it that do different things have been upgraded by different people, and you have to know how to put those components together so that they complement each other and become one program. But a lot of your computer programs are composed of other computer programs. So it goes on all the time. It's just in this case, they give you the instructions on how to do it, so you have to be able to understand what they're telling you in order to get a working copy of it. But the others, I'll put on the internet for you. On the discussion list, I'll give you a list and where you can just snap and go right to these particular things. So
The other question I had is, do these systems show that effect that you've produced, the over Unity or?
Does somebody help me?
Yeah. Is that those software, are they reproduce in software the effects of
Yes, it has a virtual oscilloscope, a virtual, every type of instrument that you would spend thousands of dollars for. It has it built right into the program so that you end up with a oscilloscope screen with all everything going on, and it reads just like ordinary. It looks like a oscilloscope, and it does all the things
And
that
they'll show
ordinary.
this effect. This isn't an effect that violates Maxwell's
Yeah,
laws.
if you put this particular thing on there, you get very startling results.
So it's nothing that would violate like Kirchhoff's current and voltage laws, because SPICE is built on that.
What you do, you pick out your components and you slide them, drag them over onto the board and put them where you want them.
Right, I know how to do it in SPICE. The question I'm having is that can SPICE show these?
He can barely hear you.
Yeah, it would be nice if the other people would know what we're talking
The point I'm
about.
trying to make is, you have SPICE simulator. Can you
Oh,
take
sure.
a SPICE simulator and show these effects? Or is this effect something that is not part of standard SPICE or a field simulator?
You can build your own components and you can tell it what you want it to do, so you can get those specs out. That's the reason why you have it, and the reason you run it is to see where the defects are and when things are happening that you don't want. And then by playing with the components, that's how you take those problems out of it.
And SPICE will show this effect.
Oh, yes.
Okay.
Not all SPICE now. It has to be a
Right, it has to have the nonlinear model.
nonlinear open system, and a lot of those are closed systems, which put you right back into Ohm's law, and you're stuck with what they
Right, the closed circuit solutions.
they want you to know, not what you're about to find out.
Thanks.
But more and more university people are using the open systems because open system things are hard to defend. And university people like things that you can do mathematically, and you always end up with the same answer regardless.
Right.
Now, that way they look good. If they're competing with something that's not going to give the answers that they want to be repeated every time, then from a university standpoint, they're in danger of needing another job. Because the university is not interested in people that can't repeat what they're doing.
Can you draw up there the the URL for this group thing you were talking about that's on the internet where you have people join or can read and ask you questions?
Okay, you want the internet thing?
Yeah.
Oh, is that what it is? Okay, I've got a lot of cards, but I'll write that on here for you. Okay, the email is, let's see, we can do bigger than that. Earthlink.net, DONSM1 at earthlink.net. The website is It's www.altenergy, whatever, pro.com. And best place to find it is go to Lycos. Well, actually, it's on all the major ones, and you can find it on Alta Vista, Lycos, and it's actually on over 2,000 servers worldwide. And you can get it whether you're in Russia or wherever. And the students at the University of Moscow and St. Petersburg literally wear me out asking questions. And there's a lot of people in Russia think that it's a real great thing. And I got one real nice response out of Finland. I've had probably 20 or 30 out of Finland, but one the other day had to do with gravity and new approaches to electromagnetics and such, and it was all stuff which does not show up in any of the textbooks. But I think you all may have seen it. It showed up as Ali Tina, O-L-I, and that first name is Ali, and last name is T-I-N-A. He's a professor of physics, and I can't say the name. It's down in Finland. But there was a little tit-tat going on the question and answer thing on Yahoo there. On that, if you go back 2 or 3 days or a week, well, you'll see it. But he had the most appropriate idea about what goes on in electricity and gravity and things like that, and it was totally out of the box. But this is somebody who's highly educated, and he speaks and writes absolutely perfect English without a glitch anywhere in it. So if you want to correspond with him, well, I'm sure he'd be flattered that you would pay attention.
Could you write his email address?
Please come up here.
Could you write his email address?
Can you write his email address?
Write his email address.
Of Alitina?
Yes.
I'll put it on the package of things so that you get it. I'll send you an email on it.
Thank you.
But anyhow, we need some more thoughts here. And
The alternate energy Procom, that's where your discussion list is at?
no, it's on Yahoo.
Okay, can you put that? That's what I want to go to.
Okay, Steve, you're going to have to help me with this.
Yahoo at
Okay.
New Energy at yahoogroups.com.
Okay. Okay, I'll put it up the top here. Yahoo
Groups.
Groups.
One word. You can go to my
That's
alternate internet
okay.
resource page
See?
off my main website,
groups.
and you can sign up for that discussion.
Okay, what's the rest of it?
.com. Is that right?
Yahoo Groups.
I think it's .com.
.com.
I'm not sure if that's the exact.
Okay, well this will get you pretty close.
But you can go to the go to my main website page.
Go to.
And then go to Internet Resources, and on that page it'll tell you where you can just click on and.
Bruce's website has instructions on how to access it. We think this is pretty close.
But before you can use that, you have to sign on to the group.
Yeah, you do have
so that's
to,
not going to even
have
work.
to sign in so that they have a record of it. But it's big enough that you probably would want to do that anyhow, and that means that you can submit your thoughts also. You just simply give them a little bit of information like your email address and your name and such, and that's pretty well it. It's not complicated, and it's not restrictive in any way, except that you're sworn to be a gentleman. That's part of part of joining the group. Lately, however, it seems as there's been a lot more going on political-wise and otherwise, and I think that's totally inappropriate. The thing is there for business purposes and not for opinions about politics and people and stuff like that. Now, some of the stuff is admittedly quite good, so even though it's out of place, I guess it's okay. But like the thing that happened in New York there, well, that just about almost wrecked the damn thing because it turned into a cat and dog fight about the pros and cons of it, and it was totally inappropriate. Yes.
I was going to mention, if people are getting capacitors of large capacity from salvage sources, they're frequently vastly mislabeled as
sure.
to what the value is.
You have to check them against other things. In most cases, I don't say most cases, but I've had pretty good luck with it. But,
well, I want to let you know there's a way to do this with large capacitors where you do not have to use a capacitance bridge, because the capacitance bridge will not give you an accurate answer.
Yeah.
The way that it can be done is by measuring the time constant, by applying a voltage and measuring the time constant to bring up to a certain value. This will give you a very accurate answer.
Is there a chart or something which you could put that on? And
there's a particular number for it to come up to a full capacity. Let's say it's coming up to 10 volts. Then there's a time for it to come up to like 6.7 volts. And that gives you the time constant,
okay,
and that
well,
has the relationship
this is
to
your
capacitance.
percent accuracy thing that they put on there because they go very considerably.
And the reason they're mismatched or they're mislabeled is because they're using a capacitance bridge to give you the measurement, and it's not accurate.
Yeah, if you have control of the situation and you don't mind spending a lot of money, you can get where they will swear to whatever values they have and actually give you a certificate on it, won't they?
But you can do it with an oscilloscope.
Yeah.
All you have to do is measure how long does it take to come up to that time constant value, and then you know exactly how much it is. That was a patent that Boeing put together, and I was part of that project. That's how I happen to know about that.
Would be nice if you put that patent number on the discussion group.
I'd have to go look it up and find it, but
well,
it works very well, and especially for these real large capacitors like a farad or 3 farads or whatever.
Yeah, well, using the powdered carbon bits, you can get enormous capacities in small packages now. So you can go up to over 5 million microfarads with present day technology, and that every day is moving out a little farther, and at 5 million you may not be much bigger than 2 shoe boxes. That used to be the size of this motel. So things have really changed. The carbon particles take enormous charges. That's what makes the difference. Yes, sir.
Has anyone ever seen an electron?
Yes, actually, when Thomson said it was out there, and 2 Thomsons, there's Lord Kelvin that's one, and then the Thomson that actually postulated the electron, and not too long ago, they actually can photograph them now.
Right.
So they know what they look like. And it turns out they look like just what they said they did.
It might help if we could see them and see what they're doing.
Yeah, well, you kind of sneak up on them. Okay?
Excuse me,
Yes.
Going back to the circuit here, you had input and output. Can you make a comment on the number of turns used? A wire?
Well,
Or the
the
length?
output will be a ratio of the number of turns on the first one versus the other one. So if you had like 2 or 3 on the first one, and you put like 10 or 20 on the other one, the output improvement would be the ratio of the first one versus the second one.
So there's no magical number, say 1 to 5, or there's no magical number, say 1 to 5 that works better.
Yeah, well, the thing is, you want to make as few of them as you have to, because it's real hard work, winding those things. And not only that, you want to do it in such a way that you can slip that rod out and use it with another device. If that one doesn't live up to your expectations, after you make the second device, you've got 2 points to work off of, so you know which way to go for the third one, and the third one you should hit pretty close to your target.
Thanks.
Okay. I think I see another question out there somewhere. Yes? Go ahead.
You had mentioned that program that's at the University of Barcelona in Spain. What is the name of the program?
Let's see, I may need some help here because I'm having trouble turning corners right now. But it's the original name for Spice something or other. It's the original one that started it all pretty much, and it's out of Berkeley, University of California, Berkeley, physics department, and it's the one that all the others basically hinged off of. So it's Spice free something. Well, it's got 2 or 3 other letters in there.
And that's the University
the
Spain,
one out of Barcelona. Basically, I don't know that anyone's given it a name, but they tell you the history of it and where it came from, and that's what it is. So they may have named it, but I don't think on the computer program it's just they use the original name, and the other components which they fit onto it have their names. So you've got something there that's got maybe 4 different components. One of those components would be your virtual test instruments, that sort of thing. And then there'll be other ones for building your own devices and fitting them into this library of things which can be used. You can build your own devices like transistors and coils and various unusual things which may or may not exist. They have over 70,000 different components in the library, and you probably can add some to it.
Okay. Thank you.
Okay. Yes, sir.
Yeah, he said something came loose here. Can we hook it back
We're
up?
going to have to go out behind the woodshed. So what do we want to do?
Oh, I just want to know, you talk...
See if it's reading anything?
Yeah.
Okay, well, why not? Let's get this one out of the way here so that...
Since you know what goes where,
actually, you're running a risk of frying this because...
Yes, you are.
Oh, great.
I have a friend of mine by the case.
These 2 things right here, and I've ruined a number of test instruments because
Can you measure something without blowing my meter?
Well, we don't know that for sure now.
I really want to do it, but I do not want to blow this meter.
I'm not trying to talk you out of it. I'm just telling you I've had disastrous experiences, and I've bought a lot of meters and things that were absolutely nice that I was real proud of, and all of a sudden one day they quit working. And mostly it was just from sitting close to that thing there when it was running.
You can't measure without touching. I can't tell you.
Yeah,
Okay.
because everything is extremely high voltage, right?
It's high frequency,
High frequency,
and
too.
high voltage. And your meter is probably, unless it's got a frequency meter on there,
I got a frequency button.
if it's got a frequency thing on there, just simply turn it on, and what you've got there, you can measure the frequency standing where you're at.
Okay, I'm reading 43.9. Now, do they need to be farther apart or what?
Well,
I'm still-
What's the scale?
It's a lot more
Kilohertz?
higher than that. Actually, it's that decimal point needs to be.
Oh, that's 2 places. I'm going to do the best I
It
can
needs to
with
be
it.
about three
Do
places.
these need to be farther apart? No.
That doesn't
Still
seem to
43.
affect it. Okay, for some reason, you're reading a component of the thing that's there, but you're not actually reading the frequency.
Yeah.
And I don't know why that is, but it's running at about 50,000 cycles a second. That I do know.
Now, wait a second. When you stepped away, it changed. Come on back over here. Okay, 43, now back up. Because it jumped up there to 80 there for a second. No, it's still at 43.
Almost 44.
Yeah, almost 40. Now it jumped to 44.
That's cycles per second. And actually, it needs about 3 decimal places on it. How many of you?
44K.
If I go to build something, this is the meter I'm going to be using.
Well,
So what meter-
you're in trouble.
I'm in trouble already. Yeah. So what kind of meter do I need to have?
You need radio type meters and devices.
Okay, give us some model numbers.
If you try to, what you need to do is go on the internet and do a search for radio test instrument, radio device test instruments, and you'll get thousands of them.
Yeah.
And
Well, I want to know what you use. That's the way I can duplicate it.
You would have to just simply come out and look, because I've got a lot of different ones. I've got Hewlett Packard high voltage, high frequency meter, and they cost a bundle.
I wanted to get into something low but easy to make, just like the one transistor thing. I want something simple. I mean, that's what everybody
The low end test instruments are things like this. This is like $7.
If I build this circuit, yeah, I can probably swing that. Yeah, if I build this circuit, or any of us build the circuit you show there with the one transistor. Okay, we can't use this to.
You can use it to a certain extent. What you do, you run that. You can set your own frequency on that transistor.
Right.
By the base deal there, the timer that you use on the base deal is opening and closing the gate there, and you can pick whatever frequency you want. So you can run it at frequencies which are in your test instrument capability.
Right.
So you don't have to go out and buy a radio type test.
Just
instrument.
lower it down.
Yeah, just
Like by a higher octave.
lower the frequency into the range that you can handle, and you're in business.
I can handle 60 hertz.
Do you drive that?
You got it.
That's what I want.
Okay.
drive
Anybody know what this thing is all about?
Oh, yeah.
Do it anyway.
That's
Hey, you want me to do it for you?
Yeah.
Okay. You know, if I drop this thing, it's going to go just like a stone. So what I'm going to do, I'm going to put it through this copper tube, and this is a neodymium magnet, and I'm going to spin it. See. Can we do that again?
Yes.
How do you explain the phenomenon?
Okay, well, let me show you what happens when you drop it. See how fast it goes? It's heavy.
Yes.
And when you put it inside this, it's non-magnetic material, copper, and you spin it. In case anybody thinks there's some obstruction in there, there's not.
Inducing its own.
This is from Bill Beatty out in California. It's one of his favorite toys. So it demonstrates the effect of gravity and nullification of gravity.
Don't spin it and drop it.
Do it?
Just drop it
Don't
straight through.
spin and drop it.
Well, the reason you spin it is because
No, don't
it
spin it.
enforces the what's going on. If you just simply drop it,
Yeah, just
it
drop
will
it.
still.
Still,
It just takes a little longer when you spin it, and that's why I did that to sort of emphasize how it was slowing things down. But you can look down in here, and if any of you went to Dennis Lee's show over in Austin the other day, he had a big one like this with a mirror set up. It had a large copper thing with a mirror set here so that you could see it, that it was going down through there. And it was projected on a screen so that you could see it in big scale. But if this had more magnets on it, it would slow it down more also.
It's a Faraday drag, isn't it? Like on the Faraday disc,
Yeah.
the drag that's being created.
So, and the faster you spin it, it also adds some to the slow down. So you can make it to where with the larger magnets and a longer tube, you can sit here half a day waiting for it to fall through there. Actually, probably 3 or 4 minutes sometimes, maybe. Where it would normally take less than, say, a second. So I'm sure you could set up a chart on that, and you could calculate how much of what it takes to neutralize gravity. You know, build a graph off of it by experimenting with different sizes and spins, and so you could actually project into something that might be real interesting. Okay?
Have another one?
Yes, sir.
Because and all the thing that you showed us or can see on your net, or you got different materials that you're using to do the coils.
Uh-huh.
Which one did you found that was the best to do
I
the
tell
coils?
you, whenever it comes to choosing wire, basically he's saying, well, there's different kinds of coils and different kinds of capacitors, different kinds of wire, and different devices have different things on them. Well, these devices occur sometimes over very long periods of time, and the basic rule of thumb is that in building this type of device, you want multi-stranded wire, which basically it's the wire used in DC things normally, and the more of those little strands are there, the better the deal, because it gives a surface for the electrons to dance around on. And by having more of the strands, you have more circular mills, which means that the total surface area is increased by quite a bit by using the multi-stranded wire. So that works in your favor. So you want to use what is normally probably called DC multi-stranded wire, and the larger the diameter, the better, but the bigger ones are hard to work with, so you pick some size which is convenient to whatever you're trying to do.
That's why you were using those
So
Lucas
that's why when you're building these things, you will fiddle to a certain extent, and you find that you're getting different results, and once you figure out which is the better way to go, then as you go along, the newer ones have the changes built in.
Is it better when it is naked or is covered? Is the same thing?
Again?
Is it better when it is naked?
No insulation.
I've got on the small one here what he's asking. Actually, I have the thing disconnected, and a couple of those things were actually touching when I was fiddling with it and got shocked. I've got them pulled apart so that it's not supposed to be doing anything, and somehow in moving it around, well, the wires ended up touching each other, and that's why I got shocked, and some of the other people that tried it didn't get shocked because I moved the wires after that happened.
Because this is looking like an antenna.
So it was putting out enough that it get your attention. It was about equivalent to a cattle probe, if you know, or the thing the police use with the electrical shock stick. it's kind of that equivalent to that. But I moved the wires that were touching, and that's why I quit working, at least for the time being. Yes.
Is there a possible relationship between these devices and gravity reversal devices?
Well, on my website, I describe what gravity is. Everyone else is taking a pot shot at it, so I figured, well, I might see if I couldn't come up with something. And what I came up with is that movement in electrical devices is in the direction of current movement. Okay. Well, all of the huge amount of electrical background, the Earth is like a big black hole, and anytime you have a solid or accumulation of something, that's because the matter is kind of hanging on to itself. It's affecting other things that are similar to it. So that's why you end up with blobs like the Earth and the planets and solar system, the sun, and all this and that. So anyhow, for that stuff to move in, it has to be affected by the gravitational effect, and somehow. So what's happening there, the energy and electricity, power and energy and matter are all in physics basically the same thing. So this movement of the energy out of the cosmos into the solar system and into the planets and such like that is the power which is spinning the Earth, which is enormous. So anyhow, this movement into this mass, which we call Earth, the energy coming in is the equivalent of, it's the friction factor of this energy being pulled into the Earth, and that's why when you fall towards the Earth. So in electrical devices, movement is in the direction of the current, movement of the current. So gravity is a friction factor of the energy moving into the Earth. It's just that it's a simple thing, and it's undeniable if the person that will think clearly. So gravity is a component of the movement of energy into the Earth. It's a friction factor related to movement. So gravity, and when some motor is spinning or the magnets are pushing each other away from each other, that's an electrical reaction there, and that effect between them is the gravitational field either pushing them apart or pulling them together, depending. So gravity is not something magical. It's not something which can't be described. It's something that you can see the effects of. You can see the effects of it, and you can describe it because it does this or that. So, and I like my definition a lot better than the one that's in the physics books.
Theoretically, you could take a flyback circuit and reverse the charge like goes to a TeV, which is positive, make it negative, and it would, by controlling the rate of charge, it would control the rate of levitation, so to speak.
Well, actually, by these quick swings of alternating current and that sort of thing, the flux, the magnetic field switching off and on, and they're actually into that right now. And by using square waves and pulsing them, they get a very noticeable change in weight of any metal device that they feed that into. So they're actually getting heavy pieces of metal lifting up and moving around. Okay, I think I dropped something there, but I don't know what it was, but it doesn't matter.
On your circuit, the base of the transistor, were you driving that with a square wave?
Well, it depends on the transistor. There's about 9,000 different ones, but they will give the characteristics of that particular transistor. So whenever you look at a chart of them, you'll be able to pick out an ordinary NPN will work on a square.
Was that a square wave you're driving it with?
Yeah, it's just actually a square wave is just simply this with the things chopped off. So it's actually the part of the energy there is being chopped off of it. So it's still this, whether it's square here or square here, and so. Yes. Oh, that's what it was. It's still lit? Okay. Yes. Okay.
You got a part number for the transistor?
NPN is all you really need to know. You go to Radio Shack, and that's a generic description of it. And the N means something in each case, and the P means something. So NPN means that it simply will work with alternating current.
How about the resistor value? The value of the resistor?
Well, as long as it will work within the voltage which you're going to propel it with, and it says on the package it's good for 25 volts or 100 volts or 3,000 volts or whatever. And as the voltage goes up, the price goes up. But you can get them for any amount and that sort of thing.
We're gonna have to wrap things up, Don.
Okay. Let's see what we're doing here.
Yeah, we're way over time, Don. We're gonna have to wrap things up.
I can't.
We're gonna have to wrap it up.
I want to wrap it up. Okay, well, I know that many of you came from long distances, and I appreciate very much, and I'm very flattered by your coming. And I'll do my best to answer other questions if you take advantage of the internet there.
You're gonna be at the social tonight at 9 o'clock, Don?
Say again?
You're gonna be at the get-together tonight at 9?
Okay, I'm supposed to tell you that after hours this evening that there's a social with niblets and maybe some beer and who knows what else.
You going to be there?
And that's on condition that you promise you won't fall in the swimming pool.
Are you going to be there? Will you be there?
I will be for a short while, but I didn't get to bed last night until about 2:30, so by that time I'll be pretty well worn out. And you see, walked off without my briefcase. This would have been much, much more interesting if I had gotten here with it. And also something I want to tell you, those of you that want books or have CD-ROMs that have a lot of stuff on it related to what we're talking about here. And those that want books, I'll make up however many we need here. So you need to email me and tell me what you want. And we have nice books, and when I do them, they're real nice. They're not, these copies have been copied 100 times before you get them, but the ones I do, I usually print them out on a laser printer, and they look fairly presentable. And the books, as they are $30, and I'll send them to you on a 2-day mailer thing, which means you get them about a week after, but I need about 2 weeks for this to settle down and have some idea how many put together. So it's a lot of trouble. You've got something that's 150 pages or so, and you make like 50 copies of it. Well, you can see how many reams of paper you got going for you. And not only that, if I make up 50, they usually sell, they're gone before I ever get them made up. So, and I do this sometimes, probably like 100 times a year. So, and the CD-ROMs with the photographs and things that you see on the internet there are on a CD-ROM, and there's a lot more besides that are with them. And some interesting folders and things which are related to what we're talking about. So the CD-ROMs would be like $30 also each. And all I need from you is you can send me your money or whatever, and once this settles down about 2 weeks and I have some idea how many to make, then I would say that within 3 weeks you would have whatever it is, and you know how to get in touch with me.
You can send those FedEx, can't you?
Yeah, and I can tell you that there's more than 30,000 copies of the book that are out there, and the book has been translated into every major language around the world. And I get, in one day I get like 200 emails from all over the world. About 20 of them are from here in the United States, and they come from very interesting people sometimes, that sort of thing. So these are people which you hear about, you know, that are in the news and books, and you never know who's going to turn up on the doorstep. I had people from China calling me, and they wanted to make a deal, and I kept trying to put them off. And so one day when they called, they asked, well, how much do we need to make this thing work? So I hadn't the slightest idea, so the number I pulled out I thought would stop it, and I said $300 million. And this was like on Wednesday. And on Saturday morning, I get a call in the airport, and these people from Dao Chiping's office in China were at the Intercontinental Airport, and they wanted to know if I could come out and pick them up. So I did, and they had Halliburton briefcases with $300 million U.S. in cash. And so I got them checked into the motel and got them a car, and every morning before breakfast they'd show up at my house, and it was like 9 o'clock at night when they'd go home, and we would sit at the breakfast table, and they'd open up these briefcases, please take, and when they were gone later in the evening, I called friends of mine who were in international business deals and things like that to find out what do you do in a case like this, and they said, well, don't. So they said what will happen will be that they told me to take the money and use it however wanted, and that they would take devices from me and charge them against it. And where they made a fatal mistake, one fatal mistake was they asked me how much does it cost to build these things, and I said, well, they're not particularly expensive, maybe a couple $100 or so if you do them in mass quantities. Otherwise, it's probably $3,000 or $4,000 or more if you do just one at a time. So anyhow, they decided that they were going to going to buy them from me at that price and credit that against the $300 million, and I had no intention of doing that. I was going to decide what the price was. They were not going to decide it. So anyhow, the only way I ever got them to leave was to tell them that whenever I got a factory, I'd be in touch. And I was finally able to get them to close their briefcases and go back to the airport. And I took them back to the airport, and they're out of Vancouver. Dao Chiping had 2 daughters, and they're both married to Americans. And this particular one was an electrical engineer and lived in Vancouver, British Columbia. And the Chinese government had put him on to me, and he still calls about once a month. So they're still interested. But this was about 3 or 4 years ago. So I have things like that happening all the time. And what would have happened if I had taken the money, I would have so many problems I wouldn't know what to do with. I did not have proper facilities or anything else, and so I used that as a way to get out of it. But if I had taken that money, I would have been in big trouble probably. You know, and not that I didn't really want to. But anyhow, that's one way to stay poor, if you know what I mean. But anyhow, I think somewhere out there must be a salad or soup or something. What do y'all think?
Groceries, yeah.
But it's great you came, and I'm real tickled to see you. And I wish you all the luck in the world. And if something doesn't work, that doesn't mean that it doesn't.
That's right.
You know, if you get the right combination, and I've tried to keep it as simple as I can, so that the options of screwing up are, you know, limited. So just do it by keying in on it, do one, and what it's not doing, well then do another one, and once you get several points here, well then you know you can find the point there where it does exactly what you want it to. So thank you again very much, and we'll see you.